Welcome to this online tutorial where we are going to continue with servos. So in this particular tutorial, we want to look at how you can use a servo in a simple project. Remember, we said in the presentation that you can use an Arduino powered weather station at your school. So this is an example of a project that you can do if you are doing your O levels, your A levels. You can propose to create an Arduino powered weather station, and here's a little project that you can embark on. So it's going to involve a lot of coding. So maybe let me take you back a bit to what you need in your connections. So you need a photoresistor here and a resistor, and what you can do is that there's something called the voltage divider rule. So you need to connect this to ground. Your photoresistor, one of the legs is going to be connected to ground, one of the legs is going to be connected here in series with the resistor, and the other end of the resistor is going to be connected to your 5 volts output on the Arduino. So you look for a 5 volts output there. Then in between here where your resistor meets the photoresistor, you're going to put a pin and you connect it to an analog pin on your Arduino. So when you connect it like that, now your Arduino is able to read values that are coming from the photoresistor. So your photoresistor will change the values depending on the light that it is exposed to. Okay, so let's try to put a code that enables the photoresistor to send values to our Arduino. And in this project, we also need to know how to use the serial monitor. This is where the serial monitor works. It's going to display for you the values that are coming from your sensor. Remember, our values run from what? From 0 to 1023. Okay, let's do that. Let's go into the coding. So you declare your variables first. So we have an integer variable here, which we're going to call light file, and we're not going to put any value there. And we are also going to have a light pin, so we need to declare that, and we're going to use our serial monitor. So you go to the voice setup there and type serial.begin. You put our code 9600. Okay, now the void loop, what you're supposed to do is to say light file is equal to analog read. So remember, you have to put this white wire here, which is midway between this resistor and the photoresistor. You have to put it on an analog pin. So you have to check on your Arduino where it's written A0, A1, A2. You can use any of those. Okay, so we are saying here the light file, this variable, which we didn't put an equal sign to put any value. We are just going to leave it like that. It's a container. It's going to get values from where the light file is going to get its the values from reading. So we are saying analog read, from reading the analog pins. Analog read which pin? The light pin. So I hope you get the logic, the connections here. We have declared a variable here. We didn't put any value. We declared this other variable, which is just the pin number that we're using, and now we are telling the Arduino that get this value, which is light file, is equal to the value that you get from your analog pin. Which analog pin? The light pin. Okay, so this is it. And we also have to remember here in our void setup, we had to declare that we're in pin mode. So the light pin is going to be used here as an input. Okay, now we have to now command our serial monitor. Here we just commanded our serial monitor to start displaying values, but what values exactly? So we have to say serial.print ln light file. So the serial monitor is going to be printing for us the light values that are coming from our photoresistor. So we want to first get the range of values. What happens when our photoresistor is in darkness? What happens if it's in dim light? What happens if it's in bright light? So we want to know the figures, then we apply some conditional logic. We can apply some equations to then drive our servo motor from those values. So we are mapping, essentially what we're doing, we're going to be mapping our light values into angles. of the servo motor. So this project involves the servo motor. So the angles of the servo motor, we're going to put a diagram so that the servo motor tells us the light level. It can show us that the light is dim, the light is bright, or there's complete darkness. So we want to try and create something like that. So hold on, let's see what's going to happen here. So you put a delay time as usual, but here since it's GT, it has to be declared here. So you have to declare another variable, an integer variable, which is dt, and it's equal to 250. So a delay time is necessary for them to function well. Okay, so so here you can check this presentation here. We are saying here geography and climate, the real world impact of Arduino and robotics. You should remember that the Arduino can be used to create Arduino powered weather stations. So this is an example of what we are looking at today. So after putting your delay time there and you upload, so this is what you're supposed to get. Let's see if we, okay, so those are the values that are coming from your photoresistor. Okay, so you now need to check if you put the photoresistor in bright light, what's going to happen, which numbers are you going to get. If you change the photoresistor and put it in darkness, or where there's dim light, what numbers do you get? So this is the function of the serial monitor. The serial monitor just shows you the values that are coming from the sensor. Okay, so just to rush to the results there, so like we said, you're supposed to now play around with your light level. You turn off the lights, you turn on the lights, you dim the lights, and read what's coming off your serial monitor. So according to this example that we're looking at here, when the lights are fully on, the value coming from our sensors was 780. So what you want to do is you want to imagine points on a line, because what we're going to be doing here is to change the light value to an angle of the servo motor. So we need to imagine that we need to put that on a graph and imagine the line and map the line that are going to relate these two. So this is what we're doing. So the 2 points of the line will be 780 for your light value, and the angle that we want is 0. So 780 would be the highest light that you get, and for the lowest amount of light we got a 150. So 150 should be equal to the highest angle that we can attain with this cheap servo motor, that's in this example is 160. So you can use 180. So these are the 2 points that we'd like to work with. Okay, so with that information, what we can do is we can create an equation that relates our angle and our light value. So here's the thing, the gradient of a line is given by your change in y over change in x. So your change in y is going to be, according to the graph, is our angle. So angle 2 minus angle 1 over light value 2 minus light value 1. So this is what we're trying to do. We're trying to create an equation that relates the two, which is your angle on the servo motor and the light value. So the gradient now is going to, now substituting those values that we got, we had a 160 minus a 0 and a 150 minus a 780, and that gives us a 160 over 630 reduced to negative 16 over 63. So that would be our gradient. So this is important. Now we can rearrange this equation to get y minus y1 is equal to our gradient multiplied by x minus x1. So putting in what we are working with here, we have angle minus angle 1 is equal to your gradient, which is negative 16 over 63 bracket light value minus light value 1. So with that, you can come up with an equation that looks like this. So it's a matter of just substituting your values and simplifying. Angle minus 0, you're left with angle here, negative 16 over 63 by your light value. So you're now multiplying this constant here with LV, and then you multiply this with a negative 780, and it becomes a positive 16 over 63 minus times your 780. So we have just simplified this equation. Now the Arduino can handle this equation, so you can put it into the Arduino in order to map your angle on the servo motor. So let's do that. So let's now come to the code and include the servo. We now know the relationship between what, our light value and and the angle, we now have an equation which we're going to also put in our code. So for the servo, remember, you need to say hashtag include this library, which is servo.h, and now we are going to declare a new variable, which is an integer variable for the pin that we're going to use for the servo. So servo pin is going to be equal to pin number 9, so you have to declare that, and you have to include another variable, which is the angle of the servo, so integer variable angle, and you don't put any value there because the angle is going to be calculated from that equation that we talked about. And you also need to type, every time you're using a servo, you need to type this servo, and then in front of that you put the name of the servo. So we're going to call it my servo. So we also need to include here our pin mode, the servo pin. So pin mode, the servo pin is going to be used as an output. We had already our light pin, which was an input. Now you need to include your servo pin as an output. And on the void setup, we also need to type in my servo.attach to the servo pin. So this is important for you to be able to do that. Okay, so let's see now what else you need to do. So after that, what we simply have to do now is to put our equation for the angle. Remember, we have to map those values from the sensor, the light dependent resistor, onto angles on the servo. So that equation is very important. We need to put it into our code. So we said our angle is going to be given by what? If you still remember, negative 16.0, you need to include those decimals, over 63 times our light valve plus 16 over 16, it was 16 times 780 over 63. So that was the equation that we managed to come up with. So this is the equation that's going to map our angle, and we should command here that my servo, we're supposed to write the angle. So this is a command that's important. My servo don't write the angle. So the angle is going to come from this calculation. It's going to be calculated from the light valve according to the relationship that we saw on the graph. Okay, that being said, now so the project now involves you writing creating a diagram. Remember, you want your servo motor to point to the correct symbol on the diagram. So this represents maximum light, dim light, and darkness here. So you want to create that diagram so that your servo can point to the right symbol on the diagram. Okay, so basically this is what you have to do. Okay, so let's see here. If the code is uploaded, what's going to happen? Okay, so that would be the diagram that you'd like to create for your project. So after uploading the code, this is what you're supposed to see happening when you turn off the lights. So when there's maximum brightness, you should see the pointer going to the correct place there, and after turning your lights down, it should point to where there's a correct symbol there, and in maximum darkness it's supposed to go to that angle. So we must be able to do that. So this is an exercise, a project that you can work with and understand all the coding that goes into that. And if you come for your training, we're going to redo this project. You should make sure that you have your Arduino board, your servo motor, and your photoresistor, and a 10 kilo ohm resistor as well. So let's meet in the next videos where we continue to explore other possible projects. We're going to come back to conditional logic and look at the smart bin project and many other projects. So I'll see you in the next video. Enjoy.